Hello everyone, and welcome to my presentation, Decoding Anticipation from Prestimulus Activity. Imagine you're driving on a lane and there's a car in front of you. All of a sudden you see these lights appear. Your reaction would be to brake in return. Now, if you had expected these red lights to appear, you would have slowed down even earlier. The decision that you made of slowing down in response to the red lights is called perceptual decision making. And the expectation that you may have had is what we would call anticipation. While it is very common in everyday life, it is quite hard to see in a lab setting. To decode what a person has anticipated, we would need some kind of label, in particular if we want to train a machine learning algorithm. However, these processes are mostly unconscious, which has this other constraint that if participants do report their anticipation, if you obtain them like this is already a type of decision. It's likely to change the brain activity and the response consequently. However, it does help to look at the behavior. As I said, the goal is to reduce response times. So longer response times could be symptomatic of incorrect anticipation. Anticipation also has this ability of pre-activating sensory areas that are concerned by the decision that has to be made later on. So from that, can we decode what has been anticipated? We go back to a very simple paradigm where participants have to make a categorical false choice. They are presented with an image of a face or an image of a number accompanied by a sound. And they have to report what they have seen or heard. We are interested in particular at the brain activity, EEG activity in that case, that happens 1 second before the stimulus that is here. We extract the alpha band activity in the temporal electrodes, as well as the occipital electrodes to distinguish the auditory and the visual areas. And we feed that to a SVM classifier. Then the labels also that we're using are the labels either of the stimulus or the labels of the stimulus where the longer response times have been inverted in order to obtain the labels of the anticipation. And what we see is that we obtain slightly better accuracy using the inverted labels compared to the non-inverted ones. Of course, this work can be improved, and I'd be happy to talk about that with you at my poster. Thank you very much.